Hello, class, and welcome to this week of CIS 101 Intro to Computers and Their Uses. In this lesson, we'll explore the fundamental components of software systems. So, we've looked at software, we've looked at operating software. Of course, those are important components of a software system. However, a software system is when you combine a few extra components to get that application to work. A lot of modern developers have different roles in software systems. We'll be exploring some of those roles. And because of kind of the division of labor, the partition of these different tasks in a software system, it's actually made it easier for modern developers to create their own software. As I'll show in my demo, some of the tools, languages I rely on. We'll discuss some vocab words on how systems communicate with each other, how they store data, and much, much more. So let's go ahead and continue. So, software systems, a little bit of review. So, application software. We've already spent quite a few weeks, right, working with different types of application software. Operating systems are, of course, essential to any software system, any software. We need to know what system they're running on. Is it an iPhone? Is it an Android? Is it Windows? Is it Mac? Software interface, another very important vocab word. This is, of course, review, right? Because we covered this when we explored menus, toolbars, search bars, and other elements, right, that users interact with um, in order to use software, right? And then, of course, we've explored installed versus web software or cloud software. And finally, we'll get to today's lesson, which is on software systems. So, software systems encompass various components that collaborate to perform tasks and deliver functionality. So, just like your application software, right? Your Photoshops, your uh, Google Chromes, your Google Docs, your Microsoft PowerPoints, they also have very specific problems. Same with the software system. Although the software system means it's not just the software, right? That final product, but it's all the different, uh, all the other softwares, right? All the other components that it relies on for it to work. So of course we have system software, right? Are you on Linux, Windows, Mac, Android, iOS? Application software, right? That's that final product, right? That the user interacts with. User interfaces, those are the actual elements on the screen. Some more components, some new components we'll be covering this week are databases and APIs. So software systems slightly different from a computer program or software. So while a computer program is the set of instructions that perform that very specific task, right? Like we said, Photoshop, Google Chrome, Microsoft Word. A software system is kind of a bigger concept. So we're talking about every single component, down to even testing the software, documenting and researching users, right, and how they interact with the system. Pretty much everything that involves in building software. That's what we talk about with software system. So first, if we're going to be talking about software systems, of course, we're going to talk about programming and programming languages. This is what enables modern developers such as myself to create software systems, to make our own. So programming languages are formal sets of instructions that allow developers to communicate with computers and create software applications. So they provide rules that's called syntax and semantics for writing code that can be executed by a computer. There's different levels of programming languages. There's the very low level, which is very close to those zeros and ones, that machine code. And then there's high level, which is very close to the English language. I specialize in high level languages, as most developers do, although I have had exposure to some low level languages. So programming languages are essential for software development. They allow developers to create applications. So they allow us to communicate with the computer, right? Tell the computer what we want in a language that it can understand. Back in the day, it was just low level, but as we've had a lot of innovation, right, in the field of software engineering, of course, there's now these really cool high level languages that can do really difficult things with just a few statements, just a few sentences, so to speak, right, of these programming languages. So, like I said, low-level languages, those are the ones closer to the machine code. Some examples of low-level languages are assembly, like I mentioned, machine language, the zeros and ones. So it's often used in embedded systems, so embedded computers. Those are your like TV remotes, your microwaves, maybe your cars, right, that have certain computers in them. Um, Usually, when you need more control over your hardware, over the power, over the computing power, the processing, right, then you're gonna lean on assembly language because it gives you more fine-tuned control over those systems, over those physical components. Now, most developers these days code in high-level languages. So that's looks a lot closer to English. We'll see an example um, of a high-level programming language in my demo for this week. So some languages, popular languages that are high level are Python, Java, C++, JavaScript. There's also some more specialized languages such as SQL, SQL. We'll cover that this week in these slides. What is SQL and how it's used for databases. So what do we use high level languages for? Pretty much anything. Scientific computing, data analysis, if you're using something like Python, web development, typically in JavaScript, application development, could be in many, many languages. We'll talk about front end and back end as well and how those languages might differ a bit. All right, so programming languages, go ahead and click onto the next video in this week, and it's just a little history on programming languages. I definitely invite you to watch just the first 5 minutes, though you can definitely watch the whole thing. But that goes kind of the arc from the very early languages to some of the modern high level ones that we still use today, such as SQL will be mentioned there, Python as well, and many others. Nowadays, there's thousands and thousands of programming languages. Each solve very specific problems. Others are more general purpose. Um, but yeah, who knows? Maybe 30 years from now, we'll have a programming languages that are so easy to use that even a beginner student, right, will be able to build some really cool things with them. So yeah, go ahead and click onto that video, and I'll see you after you watch it.